Welcome again to SmartNet 254, your networking solution center. In today's topic, we are going to configure our LAN network, where we are going to implement multi-area Ospf, and you're gonna see how you can also configure spanning tree protocol to help prevent the loops in your network. Like for example, as you can see in our topology here, I've got several links. Which help us to implement redundancy. So, but as they help us implement redundancy, loops may also occur because packets will be forwarded and forwarded back, creating loops. So to prevent that, we implement what is called spanning tree protocol. So we have got three types of spanning tree protocol. So STP, RSTP, and MSTP. MSTP is the default spanning tree. It's the default spanning tree protocol. Then we are also going to implement multi-area OSPF. Why do you need multi-area OSPF? Like for example, when we have got only a single area, let's say you only the backbone area, and you expand your network, you increase you increase the devices you have in your network. Your OSPF table will become large, and LSS will be uh, flooded. So therefore, we implement multi-area to help curb the problem. So like in our topology here, we'll use area 0 and area 1 to implement multi-area OSPF. So multi-area OSPF actually is used in a large-scale network. So even if we increase our routers, the routing table will not be flooded. So this is our plan. We are going to use VLAN 40 and 50, and VLAN 40 is on network 172.16.1.0. VLAN 50 is on network 10.10.1.0. As you can see here, .2 means that we will be using 172.16.1.2. That's what it's a .2. .3 here will be 172.16.1.2.3. When you come here to .4, it will be 172.16.1.4. The same to .5 will be 172.16.1.5. So let's jump straight away into our configuration. I will start with the access switches. So enter into your access switches and do the configurations. You undo the terminal. Then you change the device name. Access 1. On our access, we have got several interfaces, some which are access and some are the trunk port. The interface that connects to the PC, that will be act as the access port because it connects to the terminal, while these other that connect to other switches will act as the trunk port. So interface, it's an Ethernet 0/0/2. Then you give it port link type. Link type. It is an access port. Then you give it the default port. Default VLAN 40. So yes, the VLAN does not exist. We quit and we create the VLAN. So VLAN batch 40 50. After that, I go back to our interface. I give it an access. Then give it the default VLAN. Then I quit. The next, we have got how many trunk port interfaces? We have got trunk ETH1, ETH4, ETH3. All are trunk port which are forwarding VLAN 40 and 50. So one, then give it a port link type. Port link type, this is a trunk port. Then the trunk port is allowing pass VLAN 40 and 50. Allow pass VLAN 40, 50. It's the same as the other trunk port. We have got gig 3. The same, it will be allowing VLAN 40, port link type, trunk, or trunk allow pass VLAN 40, 50. The same as also gig 4. It's a trunk port allowing VLAN 40, 50. And quit and save your configurations. So we've configured gig 2, gig 3, gig 4, and gig 1. Also, we are going to enable spanning tree protocol. So we here we are told to use RSTP, rapid spanning tree protocol. So STP mode, then you give it the spanning tree protocol type. So we are done with that switch. Again, you save, say yes. Come to this other switch, say change the device name. This is an access to. Then you give it you create the VLAN. After creating the VLANs, what we're going to do is to configure the interfaces. Interface eth trunk 0/0/2. It is a port link type access. Give it an access link type. Then the default VLAN is VLAN 50. Port default VLAN 50. Then the other ones act as the trunk port link type, trunk. Then they allow VLAN 40, 50 to pass to the upper stream. Port link type trunk, port trunk allow pass. Okay. Port trunk allow pass VLAN 40, 50. Also gig 4, gig 1. It's a trunk port. Allow VLAN 40, 50 to pass. Then you go to gig 4. Gig 4 also is a trunk port, and it is allowing VLAN 40, 50 to pass. Then you quit and you configure the STP mode RSTP. to help prevent the loops in our network. So Control Z and save your configuration. Say yes. So we are through with our downward switches. We go to our distribution switch. So you do terminal. You give it the device, change the device name. The distribution switch 1. Then we are going to configure the interfaces. When you look at here, we have got gig 003, while here we have got Ethernet 001. They are different interfaces, but Huawei devices implement what is called port auto negotiation. So this gig 3 and Ethernet, they will be able to auto negotiate so that they can forward the VLAN 40 and 50. So you enter into that switch. I will configure how many interfaces we have got from gig 1, gig 2, gig 3, gig 4 up to gig 5. Both are forwarding gig VLAN 40 and 50 being a trunk port. So create a VLAN batch 4050 and enter interface gig 0/0/1. Port link type is trunk, port link type trunk, then port trunk to allow pass VLAN 4050. Then all the interfaces up to gig 5 are trunk port. Just edit. Gig 2 is a trunk port which is allowing VLAN 4050 to pass. Also you come to gig 3, enter. Is a trunk port allowing VLAN 4050 to pass. You also enter gig 4. You edit. It's a trunk port allowing VLAN 4050 to pass. Then lastly, we have got interface gig 5. It's also a trunk allowing VLAN 4050 to pass. You quit. Then we are going to create a spanning tree protocol so that we prevent loops. So STP mode, we said we'll use RSTP. Then Control Z, you save your configuration. Say yes. Come to this other aggregation switch. ATM. You change its device name. So this is distribution switch 2. So you also create the VLAN. So VLAN 4050. Create, because there are several VLANs, you must create them in a batch. So VLAN batch 4050. Then you enter in the interface view. So interface gig 0/0/1. Give it the link type, port link type to be trunk. Then it allow VLAN 4050 to pass, port trunk, allow pass VLAN 4050. Then you just edit. You have got 5 interfaces, as you can see here. There are 5 interfaces, so you just edit and they forward the same VLAN. So it's a trunk, allowing pass VLAN 40 and 50. Trunk allow pass VLAN 40 50. So we go to gig 4, give it a trunk, allowing pass VLAN 40 50. Go to gig 5, it's a trunk port, which is allowing gig 40 and 50 to pass. Then you quit, you create the STP mode RSTP Z, and you save your configuration. Are saved. Come to your physical device here. You also do the same. You save. So we are done with our aggregation switch. Now we go to our upper layer switch, the core switch. So in the core switch is where we are going to implement even Ospf to be able to communicate with the router on the external network. So our main aim here at the end of this project, PC1 here or PC2 should be able to communicate with our external server on this side. So the ERP server, we should be able to communicate. When we try to ping while we are on PC1, we should be able to communicate with this other PC, with this server on the external network. So we are going to implement Ospf multi-area, where here we have got area 0 and area 1. So we get to our device here. You undo the terminal. Then you give that device name. This is core 1. Core 1, we are going to give it the root ID. So root ID of 2.2.2.2. After that, are you going to configure the interfaces? You also, we configure the STP. So we give it STP mode to be RSTP. After that, we configure the interfaces. Let's see how many interfaces do you have. We have got from gig 1, gig 2, gig 5, and gig 3. Gig 1, gig 2, gig 5, and gig 3. We come on that interface. So we create, first of all, we create the VLANs. So VLAN batch 40, 50. Then enter the interface view, interface gig 0/0/1. Then that's port link type with trunk, then port trunk to allow pass VLAN 40, 50. Those packets of VLAN 40, 50 should be allowed to pass. Then edit gig 3 is the same. Gig 2 is also a trunk which is allowing pass VLAN 40, 50. Gig 3 also should allow VLAN 40, 50 to pass. Quit. Oh, no. Before we quit, we also create for gig 5. Should be also allowing VLAN 40, 50 to pass. Quit. After that, I come on this other also, we do the same. So, and do the terminal. Give it the name. So this is core 2. Set the mode, STP mode, RSTP. Then you give it the router ID. Router ID of 3.3.3. After that, we are going to configure the interfaces. So how many interfaces do we have? 3. So gig 2, gig 5, and gig 3. Both are forwarding the VLAN 40 and 50. So create the VLAN batch. So VLAN batch 40, 50. And enter the interface view or gig 0/0/1. The port link type to be trunk, and the port trunk to allow VLAN 40. Port trunk to allow VLAN 40, 50. I'm sorry, it was not gig. It was not gig. It was not supposed to be gig 1, it's supposed to be gig 2. That's the interface that's connected to that trunk. Port trunk. Allow pass VLAN 40, 50. Say yes and you quit. Sorry, you're not supposed to quit because you cannot configure those other gig 3. Then you give it the port link type trunk, and the trunk is allowing VLAN 40, 50 to pass. Also gig 5. Enter. Allowing VLAN 40, 50 to pass. Then you quit. You save your configuration. Say yes. The next thing you're going to do is to configure the VLAN if interfaces. So that's why we said the dot one here, you give them the IP addresses. So you enter the VLAN if interfaces. So switch. So interface VLAN if 40. On this one, you'll be given IP address of 172.16.1.4/24. All right. Then VLAN if 50. VLAN if 50. We'll give it the IP address of 10.10.1.4/24. Save. Come to this other one here. You also sign the VLAN if interface IP address interface VLAN if 40. Give it the IP address of .5, IP address of 172.1.5/24, and VLAN if 50. Give it the IP address of 10.10.5/24. Save the config. So come to our path, enter the interface VLAN, give it the IP address VLAN 40, IP address of 172.16.1. Let's check is dot. This is .2/24. VLAN 50 will be 10 IP address of 10.10.1/24. So creating the VLAN if interface is like enabling a layer 3 on that switch for communication. So we also do the same on this other core switch. First of all, let's save. Okay. Let's do it on this other switch first of all. So interface VLAN 40. Give it IP address of 17. This one will be now .3. 172.16.1.3/24. VLAN 50. Give it IP address of 10.10.1.3/24. Save configuration. After that, we are going to configure Ospf multi-area. So it's important also to know the kind of routers that we have in an Ospf. So Ospf defines several routers. So Ospf routers. So the first router is always called internal router. Internal router. That's a router inside our backbone. Also, we have got backbone router. Then number 3, we have got area border router. Area border router. Then lastly, we have got ASBR, that's the autonomous ASBR, autonomous border router. ASBR. So these are the type of routers we have. So like the autonomous border router connect one autonomous, maybe connect a network of one from one company to another company. The router that is in the border between two companies, that is what we call ASBR, the autonomous system border router. while area border router stand on between the backbone and the another area. So like for instance here, router 1 here, this one will act as the ABR. So this one is ABR, area border router. One of the interface of the area border router should be connected to the backbone area. So area 0 acts as the backbone area. So this one will act as our backbone router because it is within the backbone area. So what we do is come on this our devices and we configure Ospf. So the network that we are going to advertise are network 172.16.1.0 and 10.10.1.0. Why do we need Ospf? Ospf is a layer 3 protocol that use the link state advertisement to advertise the routes. Like let's say you want to get to network on this network of 197.136, we have to implement Ospf to advertise the routes on this other network to the external network. So Ospf should be able to understand Ospf, know the link types, the Ospf packet types, so that at least when we are configuring and mentioning those terms, you'll be able to understand what we are talking about. So let's configure our Ospf process. You can either set a process or it can be picked by default. The default process ID is 1. So initially we had set our router ID, so we'll jump straight away into area. So this is area 0. After that, we configure the network. Our network will be network of 172.16.1.0. Because it is a /24, our subnet mask is like the reverse of the subnet wildcard mask. Wildcard mask is the reverse of the subnet mask. So here we'll use our wildcard mask of 0.0.255. Then another network is 10.10.1.0, wildcard mask of 0.0.0.255. So we have advertised that our network. So when you display this, so you can see here we are advertised these networks. So in case the other routers sees those network, it should be able to know the destination. So now we also implement Ospf on this other switch. So Ospf process 1 router ID will be configured. So area is area 0. Give it the network of 172.16.1.0/0 wildcard mask of 0.0.0.255. Another network of 10.10.1.0 wildcard mask of 0.0.0.255. Quit. Control Z and we save. Those LSS are being advertised on that network. These two other switches should be now able to exchange their LSS. Then we come on this other switch, this router here. So and do the terminal, exchange the router name to 1. On this router, we are going to configure the router ID. We are going to also configure the sub interfaces. The sub interface we are going to configure on interface this one. So this interface Ethernet 0/0/1 will have two sub interfaces of 0/0/0.40 and 0/0.50, which will act as the gateway for the VLANs, for the two VLANs. We have got VLAN 50 and VLAN 40. So when we configure the sub interfaces, the two sub interfaces will act as the default VLANs uh, for these are our two VLANs. So that when the packets from PC1 is transmitted to the network, when it gets to this the gateway will know these packets are where they're destined. So we come on this router. So also remember, a router is a layer 3 device. So when a router receives a VLAN packet, the router will discard the VLAN packets. So to solve this problem, we are going to configure what is called a VLAN termination, so that when the packets are VLAN termination will help remove the VLANs when the packet arrives at the interface of the router. So remember to configure VLAN termination to terminate the VLANs on this router. So on that router, we enter the interface. First of all, we configure the router ID of 1.1.1.1.1.1. Then we enter the sub interface Ethernet Also, this router here will create our DHCP server on this router 1 to assign IP addresses to the PCs downward here. So remember also to implement the DHCP. So we enable the DHCP enable. All right, now we enter into that interface. It's trunk 0/0/0.40. That is the sub interface. So we've created that sub interface. After creating that sub interface, we're going to give it IP address of 172.16.1.1/24. Then we create a .1 queue termination, VLAN ID of 40. We terminate, meaning that it tells it when the VLAN arrive, you should terminate, you remove that VLAN 40 from that interface. Then after that, enable RP broadcast enable, excuse me, enable broadcast. Then we give the interface to select the IP address, DHCP select interface, and also for gig 50, this the sub interface. So the sub interface, sorry, tell it to, this one is VLAN 50. So while on that, you also configure the IP address of 10.10.1.1/24. Then ARP broadcast enable ARP broadcast. Then we help it to select CP. So you quit. So you quit. We are going to configure Ospf. We said router 1 here is an ABR, so it lies between two areas, area 0 and area 1. So we are going to configure the network on this side and also the network on that other side. So enter Ospf1, area 0, we get it then the network of 172.16.1.0, subnet wildcard mask of 0.0.255, also network of 10.10.1.0, wildcard mask of 0.0.0.255. Then you quit. Then we enter area 2. So area 1, I mean. The other area we are going to advertise the network of 136.136.134.0. The subnet wildcard mask of 0.0.255 is the network that is on that router there. Then you quit, save our configurations. We are going to give these interfaces Ethernet 0/0/1 an IP address. So interface it's 0/0/1, give it IP address of 197.136.134.1. Sorry, /24. Say yes. Quit. I come to this other router here. Give it IP address. Interface it's trunk Ethernet 0/0/1. With IP address of address of 196.136.134.2/24, then Ethernet 0, give an IP address of 200.12.1/24, then quit and give it the root ID. Root ID of 7.7.7.7. After that, we create the Ospf. So we have got the Ospf is on area 1. So Ospf 1, area 1. I've got two networks, that is network of 197.136.134.0, wildcard mask of 0.0.0.255. Then another network of I wanted to see something here. First of all, let's quit. We are not able to see our LSS because we undo the terminal. So quit. Then we TM. So then say yes. We want to see our LSS being exchanged. So enter Ospf 1 area 1 and display this. Have our network, add the network of 200.12.1.0, wildcard mask of 0.0.0.255. Wait. Save your configuration. Say yes. We want to see our LSS. Enable terminal. Let's save. We come to our server here. I will set the IP address to .3 and it is a /24. Then the gateway will look as this one. come to your configuration here. It's 200.12. 212.1.1. That's 255.255.255. Then our gateway will be 10.12.1.1. The IP address here is .3. You save. You save. Our network is not stable. Our network is not stable. You see the link is coming up and it is going down. So even if we try to exchange the LSS, the link is going down. You can see our neighbors here. The neighbor state is full, so meaning that the Ospfs had been established. The root ID of that one. So let's see if we enable DHCP command. Let's see if we can get IP address config. Still not able to acquire an IP address on these our devices. DHCP is enable. Let's start to ping 112.1.1. While we are on this switch here, we can ping our server on this network here. So meaning that the Ospf has been established. Yeah, it's going successful. The link here is able to ping the link on the network there. What if we are on this network? Let's see if we can still able to ping our server. Ping 200.12.1.3. It can't ping. See? So as well there's a problem. And this is our router here. Okay, let's try to advertise our network on this router here, on this aggregation switch here. So Ospf 1. First of all, let's give them a root IDs. So let's give this one a root ID of 4.4.4.4. Then this guy, we give a root ID of 5.5.5.5. So if while on this switch we can ping the server, but while you're on this switch you can't ping the server, meaning that maybe if we advertise that the network on this network here should be able to, so wait, so route ID 4.4.4.4 IP address SPF of process 1 area 0 with the network of 172.168.1.0.0.0.255, then another network of, so we see it is exchange LSS. Nice. You see, now we are able to change our LSS. The neighbor, you are told here, neighbor state, exchange start, exchange appends, then okay. So let's also configure that other network of 10.10.1.0, subnet mask of 0.0.0.255. Should also be able to see our LSS. You see, nice. Our neighbor state is now full. As you can see here, exchange starts. Where does the exchange starts? Down, neighbor exchange. Then the state is two-way. Ospf is two-way. Exchange starts. Then it's our full state. We are in neighbor state is full, so that the LS can now be exchanged successfully. We come on this other router, this other switch here. We advertise the LSS. So we give the router ID of 5.5.5.5. Then Ospf process is 1. Area, we are on area 0. Area 0, we advertise the network of 172.16.1.0, wildcast mask of 0.0.0.255. Should be able to exchange our LSS. Then we advertise that other network. See, the LSS we are exchanged successfully. We are in two-way, and the state is full. The final state is full. Loading. So how many states do we have? So we have got like how many states? Ospf states. So Ospf states. Ospf states. 1. Exchange the hello. Down state, then we go to init state. After init state, we go to extract. Init state, we go to two-way, not two-way. Extract, exchange starts, exchange start. Then the fourth state is exchange. We are find now exchange packets. Lastly, the two-way state here. I think so. The two-way. For two-way, we go to extract. After extract, now we are in full state. So these are the Ospf states. So as you can see here, the state is full. Then you configure that other network of 10.10.1.0 or wildcard mask of 0.0.0.255, and I should be able to exchange the LSS two-way. The state is two-way. Now we want to check if we can now ping our server there. So let's try and ping our server. Ping 200.12.1.3. It's going successfully now. We are now able to ping our server while we are on this hour. We are able to ping our server. Out of this side, ping 200.12.1.3. This is a successful count. We transmitted 5 packets and we've received 5 packets. And what have we obtained an IP address? Still not able to get an IP address. Let's try to assign IP address dynamically. Let's give it dot here. Let's give it dot 9. Come here. You use 172.16.1.9 wildcard mask of 255.255.255.0. Then our gateway, we'll set our gateway to .1. 172.16.1.1. Let's now try and ping our external network of 172 of 200.12.1.3. Destination host unreachable, so it doesn't know about our destination. It's transmitting to this gateway. Destination host is unreachable. Why is it that our PC is not able to obtain an IP address? Let's connect. Let's try and troubleshoot this network and see where we have the problem. Why it's not able to communicate with our external. Should be able to communicate with the external server. So guys, when we try to troubleshoot our network, we find that actually it is the link down here where we have got the RSTP, we have got the STP. That's where we are having a problem. But the link from from here up to the other side, it's okay, because when we have tried to troubleshoot it by connecting a PC to this aggregation switch, when you connect that PC and give it an IP address, the gateway of that one, it's able to ping. It's able to ping the server. We ping the server .3. It's able to ping the server. Meaning that while you're on this PC, you can ping this server on this other end. But while you're on this PC, we can't ping because our loop here has a problem. So I will check into it. We can also capture packet, and you see what happens on the each interface. Come to this, you capture packet on gig 1, and let's see. Right click, then you capture packet on gig 1. Let's capture packet on gig 1 and see. You'll be able to see how the Ospf exchange packets. Yeah, it's sending hello packets. It's sending hello packets. Should see all the stages up to where we establish a full state. Yeah. You can see what is happening here. We are exchanging hello packets. When it's done changing hello packets, and it has sent the request, our final state will be full state. So guys, that was all about this a simple LAN configuration. In our next topic, we are going to advance into a more large network, where we'll include the BGP and the ISIS. So thank you for this session. It was a long session, but it's a very important part where you implement the Ospf to enable communication to the external network.